Good morning, everybody. We'll get started here in a second. All right, let me share my screen with you. Okay, so today we are going to be whiteboarding worksheets 2, and I just shared worksheet 3 with you as well, which is we're looking at impulse momentum and conservation momentum. And we just saw that momentum is conserved, assuming there's no outside force that would cause an impulse, like friction or something like that. After we get done whiteboarding worksheet 2, we'll probably only whiteboard one problem on worksheet 3. Then I'll talk about a little bit about the test that's today. It's not I don't even think it's 100, it's not even 50 points. I think it's like under 40 points or something like that. But it closes at midnight, so it's more like a quiz, I guess. And you can do that multiple times if you'd like to, if you want to try to increase your score. And we'll also talk about the AP test a little bit. Okay, so worksheet 2, I think we've done problems 1 through 3. The problem I would like to look at first here is number 4. So we have this cart that's moving along the floor. There's this boy that's riding it. And then all of a sudden, then the boy jumps off. And when he jumps off, his speed after he jumps off is 0. And so you're supposed to write a conservation momentum equation, figure out how big the impulse is on the cart, and then finally figure out what the final velocity of the cart is. So again, I don't care if you do part A, just do B, C, and D. So let me stop sharing. This is worksheet 2, problem number 4. And I think I still have to rearrange the rooms here a little bit. Hold on a second. Sorry. Let's see. And all right, so let me open up the rooms for you. Okay, it looks like most of us are back. It also looked to me like most people had the problem solved already, so I just think I want to pick one group at random, kind of share it with you. So let me share my screen. First of all, I'll show you the picture I kind of drew. So here's my before picture. The boy is on the left-hand side. The boy is riding this cart, and I just have it moving toward the right. Afterwards, the boy jumps off and his speed is 0. Notice I didn't change the speed of the cart at all. So that's not right. I need to change that speed of that cart. So I have a question for you. If beforehand it has a certain momentum and there's the speed up here indicated on the left, afterwards, when the boy jumps off and his speed's 0, what do you think would happen to the speed of the cart if you're watching this? If you can unmute yourself, what do you think would it do? Would it speed up, slow down? What would it do?
Speed up.
Speed up. Okay, so I think it's always a good idea to kind of sketch a picture and kind of think about what the logical, common sense answer is. That way you have something to check your math with to make sure you didn't make any mistakes. So, okay, I'm just going to pick a group here at random, and I got to move this. I can't see. Sorry about that. Okay, so I agree with part D for this one here, where we're finding out what the final speed was. So they did conservation momentum. They got 4.8. I don't know that I agree with the impulse, because let me go back to the picture. The impulse on the boy over here on the right-hand side should be the same, or I should say equal and opposite to the impulse on the car. So if I find the change in momentum of the boy, it should be equal to the change in momentum of the cart. And I think that's what it's asking for. Oops, I flipped. I think that's what it's asking for in this one. Boy, this thing's constantly in my way. And I can't put it over there. Nice, okay. Here we go, out of my way. So I don't think I agree with the impulse. I think the impulse for this would be equal to the impulse on the boy, equal and opposite anyway. And so let's see, that would be 70 times 0. I think I agree with that. Minus, and actually it probably should be the final speed 0 minus 70 times 2, because that would be the impulse on the boy. And so that impulse, I believe, is negative 140 Newton seconds, which means that the impulse on the cart would be equal to a positive 140 Newton seconds. So does everybody agree with that? Are you okay with that? Any questions? But I do agree with the final speed here. I think that makes sense. So 4.8 meters per second, and that is faster than 2, so it's quite a bit faster. So I think my picture probably is correct. Okay, so the next one we're going to look at then is number 5. And number 5, again, I don't care if you do part A, you can leave that off. But what we have is we have 2 girls that are kind of facing one another on skates, and they're going to push off one another, okay? And the girls have different masses, and it says that the shorter girl, we're assuming that's a 50-kilogram girl, is moving, she's recoiling away at 50 meters per second. So before we do this one, what kind of event is this? Remember, the different type of events would be like elastic, there's inelastic, there's perfectly inelastic. What kind of event is this where they push away from one another?
Explosion.
Explosion, right? Okay, so again, I don't care if you do part A, but if you can write the conservation momentum equation. Part C says find the impulse. I'm going to add one more part. I want you to find the speed of the other girl. So like a part D, I want you to find the speed of the other girl. So if you could go ahead and do part number 5, find the equation, write the equation, find the impulse, and also find the speed of the girl. So let me go ahead and open up the breakout rooms. Oh, I got to put, why did it kick you guys out? Okay, so hold on a second.
It kicked me out trying to join back in.
Oh, okay. I don't know why I did that. And then Carter, let's see, you're in room 4. So let's see, 4. There you go.
Thank you.
Yep. Okay, so again, I want to share my screen. If anybody has questions, please ask. I think most people had this done already. So I want to show you, first of all, my picture. I made a picture here, and the reason I want to share it with you is because there's something we haven't talked about is center mass. You might see that on your, not on the test today after class, but you might see that on Monday's AP test. It kind of goes along with Unit 5. It's actually a pretty simple topic that is in that shared folder that I've made for you. So if you look up here at the top picture, this is before the explosion. And I labeled this thing called CM, this dot. That's kind of like the center of mass of the system. Since the girl on the right is a little bit more massive in my picture on the right, is a little bit more massive than the one on the left, a little bit taller. The center mass is a little bit closer to her. It's kind of like the balancing point. Imagine that you could balance that system on your finger. That's where it would balance at. What I want you to notice is when they explode away from one another, notice the center mass does not move. So look straight down below. Notice that the center mass stays right there. That's because momentum is conserved. So for the entire system, the mass, the center of mass, if you're pretending it's one particle, after the explosion, it can't have any velocity. The entire system can't have any velocity. So it stays right where it's at, the center of mass is. The thing that's interesting about it is notice the girl on the left, she's a lot further away from the center of mass than the girl on the right. The girl on the right has moved. If you compare the top picture to the bottom picture, oops, sorry, the girl on the right has moved. She just hasn't moved very far. In fact, it has to do with the two masses. So the girl on the left has moved a proportional distance away from the center mass compared to the girl on the right. It has to do with their masses. There's a proportionality there. And again, that's so that it can be balanced if you can balance it on your finger. So it has a little bit to do with torque if you're looking at Unit 5 at all, and I hope that some of you are. So anyway, let me just kind of pick a group here. Let's see what you found. Okay, so they went ahead and wrote their conservation momentum equation. In fact, they went ahead and found the speed of the more massive girl, 7.14, which is less than 0. That makes sense. And they found the impulse. The impulse was 500 kilograms times meters per second, or 500 newton seconds. Either one, it's fine. Any questions on that problem? Okay, let's talk about the next one then. Number 6. This is kind of like a William Tell thing, you know, they're shooting this arrow, except instead of an apple, it's going into a melon. And the arrow is going to go through the melon, and it's going to come out the other side, but the arrow is now slower, which means you can kind of think of it as it's transferred some of its momentum to the melon. And so the melon's going to get knocked off the person's head, and it's going to have some kind of speed. So again, I don't care if you have your part A, but please write a conservation momentum equation and then also find the speed that the melon's knocked off the performer's head. So let me stop sharing and open up the breakout rooms. All right, again, I'm going to share my screen because I think everybody's done. If you have any questions, please say something. Let's see. I'm going to show my picture first. So here's the picture. You know, they're shooting this arrow at a fruit. It's a melon on top of a person's head, not an apple. And down below on the left-hand side, that's kind of my before picture. And then the arrow is going to be going through the melon, and it passes out the other side. And the melon's going to be moving as well. So I have a question though, before we actually look at somebody's answer for this one. What kind of event is this? You know, if you had to name it, is this explode? What kind of thing is this?
Inelastic.
Yeah, I think this is inelastic. It's definitely not perfectly inelastic, right? Because it's not stuck together, so it's just inelastic. Yeah, nice.
Yeah.
Okay, so let's just, I'm gonna pick somebody at random here. All right, hopefully I'm not picking the same people. I think I already done that group, so sorry about that. Hopefully this is somebody different. All right, conservation momentum. So the initial momentum is equal to final momentum, and they got an answer of 0.3 meters per second. And that would be also, it's a good idea to keep on putting directions in. That would be 0.3 meters per second in the same direction as the arrows moving. Good. Any questions? Okay, now we're going to move to worksheet 3, and I just shared that with you this morning. And I looked at some of these, and like for number 1, I'm like, yeah, it's a cannon, and there's an explosion. Yeah, that looks easy. It doesn't look any different. I think you can handle that one, no problem. We can do it if you want, but I think you're good with it. I was trying to find something that's totally different, maybe unique. I thought this one might be somewhat unique. So try to imagine this. We have, um, in fact, did I pull this up? No, I did not pull this up. We have this truck, and this truck is moving at a certain speed, and it's going faster than it should be going. And there's a car in front of it, it's also moving, but since the truck is moving too fast, it's going to end up colliding because the driver's not paying attention. So it collides with the slower car, and as a result, now the truck is now slowed down because it, you know, hit and kind of slowed down from 14 to 12. And that car, we're trying to figure out what its new speed is that speeds up. So again, I don't care if you do part A, but could you please write the conservation momentum equation and solve part C to figure out the final velocity. So this is problem number 2 from worksheet 3. So there you go.
My
Okay.
my Wi-Fi router went down
Okay.
right when the meeting was going on, and it
Oh,
kicked me, and I
that
just had to get home and restart it.
that's not a big deal. We're coming out of our breakout rooms, and we're going to kind of go over the answer then.
Awesome. I'll open up question 6.
Okay.
I hope that doesn't happen during the AP test.
Yeah, me too. Yeah, me too. I don't know. I have any words of advice. I don't know what to say. Oh, one thing though, Carter, if that does happen, that would be a just grounds for you being able to do the makeup test then. So keep that in mind. So don't panic too much about it. So
Mm-hmm.
as people were just coming in, Carter and I were talking. Carter got kicked out because he was having Wi-Fi problems, and we were trying to brainstorm of what would happen on the test on the AP test on Monday, how to deal with that. And I don't really have a solution in terms of what you could do with the router. I don't have that kind of expertise, but to put your mind at ease a little bit, if something like that were to happen that's totally out of your control, that is grounds for you being able to do the makeup test. So let's just keep that in mind. Hopefully, knock on wood, that doesn't happen, but just in case. All right, so I'm going to share my screen with you. And I kind of wanted to show this group here how they got their answer, because they actually did it kind of interesting. They have the conservation momentum equation, but if you look at part C, they found out what the impulse was, negative 10,000. And so they used that to figure out what the change of velocity was. And they got a change of velocity of 8.3. And then they just simply added that to the original 13, and they got 21.3, just like almost every other group did. Most of the groups use the first equation here to solve for the what the velocity was. So you could do it either way. It's kind of nice. I have a question. Could everybody unmute themselves? This is my picture. I kind of drew this picture here. This is the before collision. You can see how on the left-hand side, you can see how fast the truck's moving. And then afterwards, you can see the truck slow down over here on the right. But I didn't change the velocity of the car. I'm hoping you can see the velocity of the car should be a lot faster, right? Which is what you found, logically. But there's one more thing that I want to talk about is, in fact, mute yourself for a second, because I don't want you to say anything out loud. I want you to think. The question I have for you is to think about, don't say anything, is what kind of event do you think this is? And here are the options. It could be an explosion. It could be an elastic collision. It could be a inelastic collision, a perfectly inelastic collision. So think about those. Got your answer? Okay, could you unmute yourself? And on a count of three, So like 1, 2, 3, then I want you to say, so 1, 2, 3, say.
Elastic.
Elastic.
Okay, so I heard kind of two different answers. I heard two different answers. I heard elastic and I heard inelastic. So I have a question for you. How could I know for sure? Because right now it's totally a guess. I mean, both of those could possibly be right. What's the only way that I know whether it's elastic or not?
You look at the energy before and after.
That's right. You have to look at the energy. So I'm going to go to somebody's whiteboard. Maybe I can go back to the last one. No, that wasn't the last one. I'm going to go to this one here, and I'm just going to be basically writing a conservation, actually not a conservation of energy. I want to compare the two energies, initial and final. So I'm looking at 1/2 times the mass of the truck, so I'll put MT, times the initial velocity of the truck, and that was 14 squared, plus 1/2 the mass of the car times the initial velocity of the car, which was 13 squared. So you need to know right now that I don't know what the answer is. It's not like you can really just look at a problem and go, oh, that right there, that's elastic, or that right there, that's inelastic. Usually you can't tell. Now, on the previous one with the arrow going through the the melon, that's a pretty good bet that that's inelastic, because there would be some friction probably going on there. And even in this one, it's, you know, there might be some friction, there might be some energy losses, but you can actually make the problem with just the right numbers that you could actually have energy conserved. The only way I can tell is actually doing the calculation. Now, perfectly inelastic, that one's easy to tell. If they're stuck together, you know it's perfectly inelastic. You can just look at the problem, you can tell. But I can't really tell which one's elastic and which one's inelastic until I do this calculation. And then 1/2, now I'm looking at the final. So mass of truck times the final speed of the truck, we said was 12 squared, plus 1/2 the mass of the car times the final speed we got was 21.3 squared. So the question is, I don't know what these answers are yet. So could you please go ahead and calculate both of these? And we're going to see what the answers are. Did anybody get the initial energy yet? I got a big number.
Yeah, I got 591,400.
Yeah, 591,400. I'm hoping that other people are doing this too. And go ahead and calculate.
I got, yeah.
Is it so? Okay, good. And got confirmation. And figure out the final energy too. Okay, I got another big number. Does anybody get an answer for that one?
632,981.34 about.
Okay, so 632,900 or so. I'm just gonna round it. Okay.
Yeah.
Okay, did we get a confirmation on those two?
Yeah.
Yes. Okay, so actually, you know what? I'm going to steal this and I'm going to go to my picture here. Okay, so I want you guys to look at these two numbers. Is this elastic collision? Is this an elastic collision? Yes or no?
No.
No, because if it was elastic, how would these two numbers have to compare?
Equal.
It would be the same.
They have to be the same. So that means that this one must be an inelastic collision. But I have a question for you. So this is a problem with momentum problems, because it's really hard to make sure, it's really easy to pick numbers that give you weird answers, because I want you to look at these two energies. What happened to the system? Did it gain or lose energy?
It gained.
It gained. So that's weird, right? So that probably would not happen in real life. The energy would really go down. So can anybody, let's see how fanciful your brains are. Can anybody kind of explain how it kind of somehow gained energy?
They're going down a hill.
Ah, okay. So maybe it was going down a hill. You're more, the movies go in your head are more docile than my movies. I'm thinking it hit the gas tank and the gas tank exploded or something. So it converted some chemical energy into kinetic energy. I don't know, something like that. I don't know. So, okay, sorry. All right, so let's see. I don't know that I really want to whiteboard any more problems, because I looked at the rest of these and I think they're pretty much the same thing. I do want to look at number 3 though and talk about it. So number 3 has this radon, I think. Excuse me, radium, has this radium, and it's just sitting there, and all of a sudden it decays. It turns into radon and an alpha particle. By the way, if you've ever wondered what is this alpha particle, that's just a fancy name for saying helium. An alpha particle is helium. So if you've ever had a helium balloon, like a little birthday balloon, you've actually got a whole bunch of alpha particles in there. It's just, usually we use the name alpha particle for whenever it's ionized and it's moving really fast. But when it slows down eventually and it's not ionized anymore, it's just regular old helium. But I'm hoping you see that this is just simply an explosion problem. And by the way, the people at CERN and Fermilab up near Chicago and CERN in Switzerland, where they're looking for different particles and stuff, basically what they're doing, everything they do has to do with either conservation of momentum or conservation of energy. It's pretty much those kind of things. The only reason I wanted to share this problem is because there's one thing that you might see on Monday's test that we haven't done with momentum, and that is, let's say it wasn't, notice how this is exploding just in one dimension, let's say the X direction. But what if we had something that's exploding in a plane, so in 2 dimensions? I'm hoping you can see that it's just the same thing, except now you have to worry about conservation momentum in 2 dimensions. And notice I have 2 conservation momentum equations, both in the X direction and in the Y direction. So you have to set up 2 equations to solve. It's not really that much harder because the initial momentum in this case would be 0 for both the X and the Y. Any questions about that? So you could possibly see something like that on Monday's test. It won't be on the test after class though. All right, so then what's the next thing I want to talk about? Okay, so I want to talk about the test then. So this closes at midnight. This is a little bit different. It's only, how many points is it? It's actually only 38 points. It's actually 36 points. The test is only 36 points, so it's more like a quiz. You can get 2 points of bonus though. Here's the deal though. There are some multiple choice questions. There's some calculation questions where you just put in the number, and there's a few essay questions. Those essays, I shouldn't say essay. There's a few questions where you have to explain something or describe something. I grade those. The computer can't grade those. So even though you can do this multiple times, I'm only grading the last submission that you have. So the reason why I tell you this is the computer's going to grade 22 points of it. And so if you're getting less than 22 points, then yeah, if you want to go ahead and take it over again, you can. But once you get 22 points, if you think your narratives were pretty good, then I just leave it alone. Okay. So I don't know if that helps out a little bit. There's no code for this. It should be open right after class. Okay, I want to go back to talking about the AP test just a little bit more. I'm hoping that you went into school to pick up the packet. Some of you I still haven't got an email from. If you could please send me an email, that way I know that you got it. Don't forget there's kind of a link here that you could do a practice test. I'm really hoping that you do some of those practice tests and you look at my practice answers. The College Board is really recommending that you do copy paste, but I want you to understand it after you, let's say you look at the question and then you look at my sample answer and you're like, wow, you know, English is just not my thing. And I'm not so sure that I do very well at that, but I would do really well with, I don't know if you could see this here. I do really well with just simply drawing a force diagram and an equation and stuff like that. I could do that. Well, if this is what you're better at than writing it out in words, okay, well then maybe you should go ahead and take a picture of it. In fact, you can save this picture as a PDF. You should probably go ahead and start practicing it now. That's why I give you those problems. Go ahead and practice. You can save it as a PDF, which is nice because if you save it as PDF, not only will the graders see your words on there, by the way, even if you do it this way, please write some words down. But they'll be able to see your force diagrams and equations and stuff like that if you save it as a PDF. I don't know. Do you guys have any questions for me? I wish I could give you more advice, but the College Board just is not communicating very well, and I'm getting so much conflicting information. I will say that I didn't say this to the other class, and I probably should have. Every year, I usually have a parent or a student that is worried about their scores. I really don't think it would affect your college admission if you do poorly or something. I don't think it would. But if that really is a concern of yours, you're trying to get into Harvard or something like that, and that really is a concern of yours, you know you can go into your College Board account and you can say, don't send it to Harvard. That might be something that you might want to think about doing. the thing is, even after you get the scores, let's say you find out you did well on it, then you can go back in and have it sent anyway. Now it will cost you a little bit, but it's not that much money. It's just like, I think it's $25. Might be worth it. So I don't think it would prevent you from going to college, but I do know that sometimes students get worried about it. I don't want you to worry about that kind of stuff. You can fix that. Okay. Any questions? Well, I'm not going to see you anymore, so this is it. If you have questions, I guess over the weekend, give me an email. That's it. See ya. Bye.
Thank you.
Bye.
Thank you.
Bye.
See ya.
Thank you.
See ya.